In this video, we'll be learning how to evaluate logarithms. And to do this, we'll be working through a few examples. But to begin with, let's just remind ourselves of the following. When we write log base b of some number a equals to x, we can always rewrite this in exponential form. And in exponential form, this would look like this. b raised to the power of x equals to a. Now, it's important to realize that both of these expressions are saying the same thing. Nevertheless, it's often easier to work with the exponential form than it is to work with the logarithmic form. Now, let's see how we can use this with a few examples. Let's say we're asked to evaluate log base 2 of 16. Well, to begin with, it's a good habit to say that this must equal to some value x. And now that we've done this, we're going to go ahead and rewrite this logarithmic expression in exponential form. And since the base here is 2, this would look like 2 raised to the power of x equals to 16. Now, thanks to this step, we have now turned this logarithmic equation into an exponential equation. And we should be quite comfortable solving this. The trick, remember, in an exponential equation is to make sure that both sides of the equation are written in the same base. And since we know that 16 equals to 2 to the power of 4, we can rewrite this as 2 to the power of x equals to 2 to the power of 4, which leads us to x equals to 4. In other words, the final answer, log base 2 of 16, is equal to 4. And we're done. Let's look at another example. Let's say we're asked to calculate log base 3 of 1 over 9. Well, again, to begin with, what we'll do is we'll say that this must equal to some value x. And now we're going to rewrite this in exponential form. So in this case, the base is 3, so we can write this as 3 to the power of x equals to 1 over 9. And just as for the previous example, the trick here is to make sure that both sides of the equation are written as powers of the same base. Well, in this case, we know that 9 equals to 3 squared, so we can say that 3 to the power of x equals to 1 over 3 squared. And using what we learned about negative exponents, we can write 3 to the power of x equals to 3 to the power of negative 2. And now that both sides of this equation are written as powers of 3, we can equate the exponents and say that x equals to negative 2. In other words, we now have the answer. Log base 3 of 1 over 9 equals to negative 2. Now let's look at one more example. Let's say we were asked to calculate log base 9 of 3, and we'll just say equals to x again. Well, to begin with, let's just rewrite this in exponential form. In this case, since the base is 9, that would be 9 raised to the power of x equals to 3. And just as for the two previous examples, the trick here is to make sure that both sides of this equation are written as powers of the same base. Well, we know that 9 equals to 3 squared, so let's just go ahead and say that the left-hand side can be written as 3 squared to the power of x equals to 3. And now, using our laws of exponents, we know that the left-hand side will turn into 3 to the power of 2x equals to 3. And remember, when we write 3, that's the same thing as writing 3 to the power of 1. So we now have our exponential equation, and both sides are written as powers of 3. So we can just go ahead and equate the exponents. That would be 2x equals to 1. Solving this leads us to x equals to 1/2. And so we have our answer. Log base 9 of 3 is equal to 1/2. And there you have it. That's how we can evaluate logarithmic expressions by rewriting them in exponential form.